Hi, I'm Joe Paiva. Welcome to course number 3, part 3 of the Introduction to State Plane Coordinates. In this series, we're talking about the concepts. We're giving you an overview of what the concepts are involved in the state plane coordinate system in the United States. Talk a little bit about how the projections work and what the scale differences mean. Talk about how the mathematics operates rather than how to do the mathematics. In other words, we don't go through the complex mathematics of actually computing the projections. These days, most people have software in their field devices or in the office systems to take care of that, but understanding what is going on to avoid the problem of garbage in, garbage out is even more important. Then we'll talk about some of the practical applications in the field, in the office, and especially in communicating state plane coordinates and the concepts of state plane coordinates to people on your own team as well as outsiders such as clients and third parties such as government agencies. So in general, this course stresses the understanding of the theory and the mathematics used in the system at a conceptual level rather than getting into the actual mathematical detail. Now there is some mathematics that we'll go through to illustrate how some of these projections work and the scale factors are applied, how grid mapping angles are used and so forth. But those are all relatively minor, relatively simple concepts that can be understood well so that when you look at data that someone else has given you or when you look at your own data that you created to deliver to somebody, that you are able to tell if it looks good or passes the smell test, let's say, or if there's some major problem with it. So in this course, we'll talk about how we characterize the distortions in the projections, the two types of projections that are used in the state plane coordinate system. And we'll talk about the particular zones' constants and how to understand them, how to relate to them, how to understand how they're applied or considered. We'll talk a little bit about the concept of grid declination or mapping angle. We'll just briefly touch on the geoid. It's not a major factor with state plane coordinates. And then we will talk about some of the beginning calculations. And really more conceptually, it will be only in the next one where we'll start to do some simple addition, subtraction, multiplication, and division. So with transverse Mercator projections, the scale basically varies from east to west, but stays relatively constant going from north to south. And the scale is true at the secant line, that is where the cylinder punches through the earth at each end, at each edge of the zone, about two-thirds of the way, two-thirds of the middle of the zone. And then on transverse Mercator projection, you should know that after it is on the grid, that all geodetic meridians, that is north-south lines or lines of longitude, are still curved on the projection converging at the pole. And I'll have an illustration of most of these concepts in different ways, in different slides, but I just wanted to put this in text so that you have it as a good marker. Now, if we go to the globe, you will see that the scale, as I said earlier, varies from east to west, but stays constant north to south. And that's because we have the curvature of the cylinder matching approximately the curvature of the earth, so there's very little distortion as one proceeds north-south.